Today in Lesson 85, we're going to be covering something that should be pretty familiar to you. It's solving problems using the Pythagorean theorem. Okay? Now, in a right triangle, in a standard right triangle, guys, the right triangle has some specific parts here. Now, generally speaking, in a right triangle, we're going to be labeled A, B, and C, where C is the right angle, and then the opposite angles, or the sides opposite the angles of it, will have the lowercase letters A, B, and C. All right?
I have a question.
Yes.
How is this going to be an easy lesson?
It just is an easy lesson because you've done it a lot of times.
Done it.
Yes, you have.
I was in reach.
The Pythagorean theorem says a squared plus b squared equals c squared. And that relationship is always true for any right triangle. The sum of the squares of the legs is equal to the square of the hypotenuse. Do y'all remember seeing The Wizard of Oz, where the scarecrow finally gets his brain, and he snaps to attention and points his finger to his head, and he says, the sum of the squares of the legs of a right triangle are equal to the square of the hypotenuse. He's finally arrived. He's finally reached. That's exactly what he said. He said the Pythagorean theorem. And but the Pythagorean theorem is far more famous than The Wizard of Oz. Okay? This is, y'all listen, the Pythagorean theorem is one of the most important theorems in all of mathematics. The Pythagorean theorem is foundational to the distance formula. It's foundational to a lot of stuff in calculus. The Pythagorean theorem is a huge, huge, huge concept. The Pythagorean theorem is always true for all right triangles. And if we are missing the side, one side, if we're missing the hypotenuse or if we're missing a leg of the right triangle, we can solve using the Pythagorean theorem. And so that's what we're kind of looking for. Use the Pythagorean theorem to find the side of this missing triangle. I know that's difficult for you to see. That's a 6 and an 8. Okay? The 6 and an 8. So this will be 6, and this is ocho, and that's C. Okay.
So is it 6 squared plus a squared will equal c?
That's exactly what it is, Mac. It's 6 squared plus 8 squared, but I think you said C. It's got to be C squared.
I meant to say c squared, but
Yeah.
I thought
So 6 squared plus 8 squared equals C squared is exactly what we're going to use to solve for C. And that's going to be pretty simple, right? What's 6 squared plus 8 squared? 36 plus 64 is 100. 100 equals C squared. And so C has to be 10. Now we're going to learn a little bit later that if we solve a squared equation, that the answer is going to be, there's going to be two answers. Positive or negative 10 can be squared to be C. But why are we only interested in a positive value for C here? You can't have a negative distance. Okay? Now, when you get into trigonometry, and even maybe in some algebra 2, you'll do some triangles where the triangle is sketched in the coordinate plane, and some negative values can come into play. But that's just to label a point. All right? The distance, the length, which is what we're finding here, is the length. A length or a distance is always positive. So we just want positive 10 as our solution. Okay? That's pretty easy, isn't it, Mac?
yes, sir.
All right, so let's have a look at this one. Find the length of t to the nearest tenth. Now, in this particular problem, we're given the hypotenuse and one of the legs, and we're having to find a missing leg. So in this particular triangle, it's not labeled A, B, and C. But this is, let's call that A, let's call this B, and let's call that C. Right? So the Pythagorean theorem here will be 4 squared plus t squared equals 7 squared. Now we have a nice little equation that we can solve. 4 squared is what? 16. So I'm going to subtract 16 from both sides. And I'm going to get t squared equals 49 minus 16 is 33. Now this says find to the nearest tenth. So what are we going to do to find to the nearest tenth? Yeah, we're going to use the calculator to estimate the square root of 33. It's going to be a little less than 6, right? 5.74 approximately. This says to the nearest tenth, so let's do 5.7. T is approximately 5.7.
And is this just all the lesson?
Basically, there's one other little twist we're going to put on it. We're going to use the Pythagorean theorem to prove that something is a right triangle. Okay? That's not difficult, though. All right, let's have a look at another one. This is a great Monday lesson, isn't it?
Yes.
Yes, Mr. Hinton, it is.
Yes.
All right. Now, this one, which side is the hypotenuse? Because that's what's important, right? Square root of 61 is the hypotenuse. If you're ever in question, one of the inequalities that we are going to look at, and we'll talk about this a little bit more in detail in one of the coming examples, the 90-degree angle is the largest angle of a right triangle, right? And basic triangle inequality rules tells us that the longest side of any triangle is across from the largest angle. So the hypotenuse is always the biggest side. It has to be, because it's across from the largest angle. And that makes sense. If two angles are opening up, the more the angle is opening up, the longer the side it's going to create. It's going to sweep out a bigger side, right? So the largest side is across from the largest angle. So my hypotenuse is square root of 61. So the Pythagorean theorem here is going to be k squared plus 5 squared. I'm going to go ahead and write that as 25.
Does it matter, like, if you use b squared or a squared?
I want you to use the variable that's given.
Well, no, like, what?
No, a squared plus b squared is the same as b squared plus a squared. The legs are completely interchangeable. It doesn't matter which one is a and which one is b.
So, like, the order doesn't matter?
The order doesn't matter for a squared and b squared. That's right. All right, 25. Now, what do we get when we square the square root of 61? What happens to the square root when we square it? It goes away, right? Because the square root undoes the square and vice versa. So we'll have k squared plus 25 equals 61. We're going to subtract 25 from both sides. And 61 minus 25 is 36. Is that right?
Yeah.
That's good. I like it because it's a perfect square. And that means that k has to be what? 6. If we were just solving this algebraically in an algebra scenario, it could be positive 6 or negative 6. But in this case, we're talking about the distance, the length of a side. The length or the distance is always going to be a positive quantity. All right. Now, I think we're done. Well, no, let's do this one because this one has got an important concept here. M is the hypotenuse, correct?
Yes.
So I've got 8 and 12 as my A and B. So the equation will be, it will be what? 8,
8 squared plus
boogity
12.
boogity. 8 squared plus 12 squared equals M squared, right? So that will be 64 plus 144 equals M squared. Now, remember what the direction said. What did the direction say? In simplified radical form. So I'm not going to use a calculator for this. I'm going to simplify the radical. This will be 208 equals m squared, which means m squared equals the square root of 208. Or excuse me, m equals the square root of 208. I want to simplify that, so I'm looking for the largest perfect square that will go into this. What's the largest perfect square that will divide into 208?
16.
16 goes
4 times. 13 times.
13 times. So this is 16 times 13. And you can find those factors using your calculator. We're just going to go through our list of perfect squares and find the biggest one that will go into it. And now I can take the square root of 16, which is 4 times the square root of 13 equals m. And that's a simplified radical form answer for the problem.
Is that all?
That's it. Right? Now, this is going to... I don't think this will make the quiz. Now, this is it. This is a biconditional statement. You don't understand a whole lot about what biconditional means at this point. You'll learn a lot about it in geometry. The Pythagorean theorem is a biconditional statement. Okay, so if a squared plus b squared equals c squared, then the triangle is a right triangle. If it's a right triangle, a squared plus b squared equals c squared is true. But if a squared plus b squared plus c squared is true, then it's a right triangle. You can use the Pythagorean theorem to prove that a triangle is right or not right. Okay, in geometry, you'll learn how to use this Pythagorean relationship to prove whether a triangle is acute or obtuse. But in this case, we just wanted to determine if it is a Pythagorean triple. In other words, we want to know, is this triangle a right triangle or not? Is it a right triangle?
No.
Is 9 squared plus 40 squared equal to 41 squared?
Way.
That's the question. If it is, then guess what? We have a right triangle. If it's not, then we do not have a right triangle. 9 squared plus 40 squared, what is that? 1,681. Is that equal to 41 squared? What's 41 squared? 40 times 40, 1,600 plus...
1681.
It is 1681? 1681 is true. And so, yes, this is a right triangle. It is Pythagorean triple. If they're not exactly equal to each other, it's not a right triangle. Okay? Is everybody okay? So we're using the Pythagorean theorem in this instance to show that something is a right triangle. What about 8, 10, 12? Which side has to be the hypotenuse if this is a right triangle? 12. The largest side is always your right angle, or right across from the right angle, making it the hypotenuse. So 8 squared plus 10 squared equals 12 squared.
No.
That's 164 equals 144. They are not equal, so this triangle is not right triangle. Does anybody know what a not right triangle is called? No? It could be obtuse or it could be acute, but it's either right or not right is oblique. So all of our acute and obtuse triangles are called oblique triangles. And that, again, you'll learn that in geometry. That's more of a geometry concept than an algebra concept. What about this one?
Whoa.
Now this is where it comes in handy being able to estimate square roots, right? Which one of these is the largest side?
170.
The square root of 170 is the largest side because it's bigger than, what's the 49 or 121, the squares of the other two. So it is a right triangle. Why is it a right triangle, Carson? Okay, because 7 squared plus 11 squared equals 170 squared. Square root of 170 squared is just 170, right? And that's 49 plus 121. 49 plus 121 is indeed 170. So 170 equals 170. And guess what? That's a right triangle. Well done. So you can see how the Pythagorean theorem can be used to help us. Tons and tons and tons of practical applications of right triangles in real life. I used one this weekend. I was with Kirk and his dad at their house working on a trailer, and we had to do some measurements, pull a tape measure to see if this coupler we were putting on this trailer was in the center of the trailer. And we used right triangle measurements. I didn't take a moment to stop and teach while I was there, but we used those measurements to see if indeed we had it squared up correctly. So Pythagorean theorem comes into play when you're laying floors. Like if you look at the floor, look at the ceiling, you want everything to be nice and square. You want 90-degree angles to assure that you have a 90-degree angle. You use Pythagorean theorem to make sure that you have a right angle. Okay, it's big. It's a big concept. The ladder in the diagram satisfies the 1 in 4 rule, a rule of thumb for safe use of ladders. This rule states that when the bottom of a ladder is positioned X feet from the base of the building, the top of the ladder should reach a point 4x feet off the ground. Find the length of the ladder in the diagram and round your answer to the nearest tenth of a foot. So how long of a ladder would we need to reach 20 foot up a building? Not a 20-foot ladder, because that ladder would be standing straight up in the air. So we need a 5 squared plus 20 squared equals a c squared ladder. So that's 40 plus 25. Y'all got to get your assignment. Don't get in a hurry. That's 65 equals c squared. Square root of 65, they want it to the nearest tenth. That means we're using a calculator. So what would this approximately be?
Wouldn't that be 400 squared?
Yeah, 425. I'm sorry, 425. I got into a hurry. 20.6 approximately. Sorry guys, it's 425 there, not 65. All right, homework. Hey, let's make it a great week. Remember, a quiz on Wednesday.